Okay, this is this is proof of circle theorems, and A, B, C are points on the circumference of a circle, and the centre is O, and prove that AOC is twice the size of angle ABC. So the idea is that the angle on the circumference is half that at the centre, if it's part of a chord. So you must not use any circle theorems in your proof. Right, so what we do know is that we have two triangles here, and they're both isosceles. And they're both isosceles, and isosceles triangles are quite important in this case, because so OBC, there we go, this being O, this being B, this being C, these are the same length because they're the radii of the circle. And same with ABO. So it's got the same thing. It doesn't have the same length there, but that is O, that is B, and that's A. Okay. So we know, based on this, that this one, Y, and this one, Y, are the same. Okay, so that's Y, and this is 180 minus 2Y. You can see that because the whole thing adds up to 180. So therefore, the this bit here would be 180 minus 2Y. If we call this X and we call this X, then what we know about AOB is that this is 180 minus 2x. And now we have the beginnings of the proof. So we know ABC, if we look at that, equals x plus y. And we know that AOC, well, we don't know that, do we? So we're trying to find this bit there. So what we're going to do is we're going to assume that the points around, or at least the degrees around a point, equal 360. So to find AOC, we have to do 360 minus 180 minus 2y minus 180 minus 2x. And that will equal 360. So this is a little complicated. So we go 360 minus 180 is 180, minus 180 is 0. But then minus 2y is going to be plus 2y. And minus 2x is going to be plus 2x. So that means that AOC, this bit here, is 2y plus 2x. So we're saying that AOC is twice the size of angle ABC. And that works because ABC equals x plus y. AOC equals, I think I meant to do that, 2x plus y. Therefore, AOC equals 2 times ABC. And that's that proven. Now, let's look at the next one. Okay, this is almost the same question. So ABC are points on the circumference of a circle, and AOC is the diameter of the circle. Prove that ABC is 90 degrees, and you must not use any circle theorems. If you look, the difference between this one and this one is that this one in the middle is straight, which means that the angle at AOC, if you think about it, is 180. And then that means that we always have 90 degrees there. So we do the same thing in order to prove it, but it really is kind of the same. So we'll just create two triangles. One is going to have y and y there. And then that would be 180 minus 2y. You see where this is going. This is x, and then this would be, oh, hang on, x, because those are both radii, and then that would be 180 minus 2x. It is the same proof. And then all you're doing there is you're saying, we know that ABC equals x plus y. We also know that it equals 90 degrees, but we're basically, I shouldn't really say that. Oh, okay. More importantly, we know that AOC equals 180. Okay. Now, I'm now going to prove to you that AOC equals 180. And we're going to do it by doing, we know that we can do the same thing. So 360 is all the things around that point. And so 360 equals 180 minus 2x plus 180 minus 2y. And that equals, so that's 360 equals 360 minus 2y minus, or rather minus 2x minus 2y. And that means that we can take 360 off both sides, and we can add, so that's 0 equals minus 2x minus 2y, and we can times both sides by minus 1, and we get 2x plus 2y equals 0. So that equals 180, because we can see that. And we know that ABC equals x plus y, so therefore 2x plus 2y equals 180. And if we divide by 2 on both sides, we get x plus y equals 90. And that's how you do that. And they are, I think, the same proof, but I'm not sure I should have been so relaxed about the fact that they were the same proof.